In this video, we're going to look at how to find the two square roots of a complex number. And for our example, the complex number is -5 plus 12i. To begin with, we're going to let x plus iy equal to the square root of -5 plus 12i. And it's important to remember that xy are real numbers. First step, we're going to square both sides so that we get x plus iy squared on the left-hand side, and on the right-hand side, we're going to square the square root of -5 plus 12i. Now on the left-hand side, x plus iy squared is simply x plus iy times x plus iy. On the right-hand side, when we square it, the square and the square root will cancel out so that we only get -5 plus 12i on the right-hand side. Next, we're going to expand the left-hand side. So we have x times x, which gives us x squared, x times iy, which will give us plus ixy, plus iy times x will also give us another plus ixy, and iy times iy will give us plus I squared y squared. And remember, I squared is equal to -1, so this term will be equal to -y squared. On the right-hand side, we still have -5 plus 12i. And what we're going to do here is we're going to group the real terms together, x squared minus y squared. We're also going to group the imaginary parts together so that we get plus 2xyi, and this is still equal to -5 plus 12i. Now that we've got the equation x squared minus y squared plus 2xyi is equal to -5 plus 12i, our next step is to equate the real and the imaginary parts. So from this equation, the x squared minus y squared is the real part on the left and -5 is the real part on the right. So equating the real parts, we're going to get x squared minus y squared is equal to -5. And we're going to call this our first equation. If we equate the imaginary parts, on the left, we're going to get plus 2xy, and on the right, it's going to be plus 12. So equating the imaginary parts, we're going to get 2xy is equal to 12, and then if we simplify this and make y the subject, we're going to get y is equal to 6 over x. And we're going to call this equation 2. Our next step now is to substitute equation 2 into equation 1. And the purpose of this is we want to form an equation in terms of the variable x only. So from equation 2, y is equal to 6 divided by x, we're going to sub into the first equation, and we're going to get x squared minus 6 divided by x all squared is equal to -5. And expanding this one, we'll get x squared minus 36 divided by x squared, which is equal to -5. Now that we've got an equation in terms of x, our next step is to solve for the values of x. I'm going to start by multiplying both the left and the right-hand side by x squared. And the reason is because I want to get rid of this x squared when I expand it. So when we expand the left-hand side, we're going to get the equation x to the 4 minus 36, and on the right-hand side, we still have got -5x squared. We're then going to move this -5x squared term over to the left. So our final equation is x to the 4 plus 5x squared minus 36 is equal to 0. Now at this point, some of you may recognize that this is actually a quadratic equation in disguise. So we're going to solve it using the substitution method. We're going to let u equal to x squared. So this equation, x to the 4 plus 5x squared minus 36 is equal to 0. We can express x to the 4 as x squared all squared plus 5x squared minus 36 is equal to 0. Then we're going to replace all these x squared terms with the variable u. So we have a quadratic equation in terms of u, which is u squared plus 5u minus 36 is equal to 0. Then we're going to factorize this monoquadratic. We need to find two numbers that multiplies to give -36 and adds to give 5. The two numbers would be +9 and -4. So this factorizes to u plus 9 times u minus 4 is equal to 0. And of course, if two factors multiply to give 0, this means that either one or both is 0. So if u plus 9 is equal to 0, we're going to get u is equal to negative 9. Or if u minus 4 is equal to 0, we're going to get u is equal to 4 as our other solution. Now, if you remember at the beginning when we defined the square root of negative 5 plus 12i as being equal to x plus iy, one of the conditions was that x and y must be real numbers. So since x is an element of real and we define u being equal to x squared, this means that u is equal to x squared needs to be a positive number. So this means that u cannot equal to negative 9. We need to reject that. And so we can only have u is equal to x squared being equal to 4 only. And therefore, we get two solutions for x, which are x is equal to negative 2 or positive 2. Our last step now is to find the corresponding values of y, and hence we'll get the final solution. So remember the equations we got from equating the real parts and imaginary parts? They were x squared minus y squared is equal to negative 5, and y is equal to 6 divided by x. So just then, we had x is equal to 2 and x is equal to negative 2. So when x is equal to 2, we're going to sub into the second equation, and we're going to get y is equal to 6 divided by 2, which is equal to 3. Or when x is equal to negative 2, again substituting into the second equation, we're going to get y is equal to 6 divided by negative 2, which is equal to negative 3. And remember, we started off by defining x plus iy as being equal to the square root of negative 5 plus 12i. So this means that we have got two solutions for the square root. The first is 2 plus 3i, and the second square root of negative 5 plus 12i is equal to negative 2 minus 3i. And that's it. Thanks everyone for watching the video. I hope you guys did find that useful. For more videos on this topic or other topics, please do check out our channel. We do release videos weekly, so if you haven't already, don't forget to subscribe. We would love to see you all in the next one. Bye for now.